After the world witnessed the eruption of Hunga Tonga from space, a new question began to echo throughout the scientific community. Can we detect eruptions like this before they happen? And more importantly, can we stop them from becoming disasters? In this episode of Infinity Beyond, we explore the technology that scientists are using right now and the innovations coming next to monitor volcanic activity around the globe, especially under the sea. First, it's important to understand that satellite monitoring has revolutionized how we study volcanoes. Using a network of Earth-observing satellites, scientists can now detect even the smallest changes in a volcano's surface. These satellites use a technology called INSAR, Interferometric Synthetic Aperture Radar, which sends radar signals down to Earth and measures the ground's movement with centimeter-level precision. Before Hunga Tonga erupted, INSAR had already detected subtle uplift of the seafloor in the area, indicating that magma was rising beneath the surface. But unfortunately, the region lacked real-time systems to trigger a public warning. Tonga's isolation and limited infrastructure meant that the volcano wasn't being watched continuously. By the time the eruption occurred, it was too late for any alert to reach the coastal communities in time. That's where new global monitoring systems come into play. Agencies like NASA, NOAA, and the European Space Agency are now coordinating to ensure that satellites pass over high-risk volcanic regions more frequently. Some satellites are equipped with infrared sensors, capable of detecting changes in temperature or heat anomalies, even if the volcano is underwater. But satellites aren't the only tools. Scientists are also deploying ocean-bottom seismometers, specialized sensors that sit on the seabed and listen for tremors. These instruments are connected through a network known as seafloor observatory systems, which can detect early signs of magma movement. If something changes, like a sudden tremor or shift in pressure, it can send data back to researchers in real time. Another game changer, artificial intelligence. AI is now being used to scan satellite images, seismic patterns, and gas emission data to identify early signs of eruption. By training machine learning models on thousands of volcanic events, scientists can create predictive models that issue warnings, sometimes days or even weeks before a major event occurs. The Hunga Tonga eruption exposed a critical weakness in our current monitoring network. Underwater volcanoes remain the least understood and least observed. Unlike land-based volcanoes, which are often ringed with sensors, many submarine volcanoes have no instruments near them at all. And yet, 70% of Earth's volcanic activity occurs underwater. One promising solution is the deployment of autonomous underwater vehicles, AUVs, robotic submersibles that can map the seafloor, detect temperature anomalies, and measure gas emissions. These robots can operate for months at a time, swimming over vast areas to collect data that would otherwise be impossible to gather. Meanwhile, new satellite missions like Sentinel-1, Landsat-9, and TerraSAR-X are being launched with the goal of improving volcanic surveillance. These satellites can deliver updates as often as every 6 hours, providing near real-time insights into volcanic changes. But even with all these tools, predicting an eruption is still more art than science. Volcanic systems are incredibly complex. Not all uplift leads to eruption. Not all earthquakes signal magma. And not all eruptions are catastrophic. What made Hunga Tonga unique was not just its scale, but the lack of precursors. There were few tremors. There was no significant sulfur emission spike. The system went from quiet to apocalyptic in less than 24 hours. That has led many volcanologists to propose a new model for submarine eruptions, one that includes hidden magma chambers and hydrothermal instability as triggering factors. The good news is that this eruption has sparked a global effort to improve early warning systems. Tonga is now receiving support from international partners to rebuild and modernize its volcano monitoring stations. Satellite access is being expanded, and the event has prompted the Pacific Tsunami Warning Center to re-evaluate how submarine explosions are detected and analyzed. The world is waking up to the fact that our greatest threats may lie beneath the waves, hidden but not invisible. At Infinity Beyond, we believe that understanding these dangers is the first step in protecting lives. And as we continue to explore the frontier between Earth and space, we invite you to join us, because the next eruption could come from anywhere, at any time. In Segment 4, we'll explore how this eruption affected Earth's atmosphere, and whether the massive plume of water vapor could change global weather patterns in the years to come.